Alrighty, good morning everybody, and welcome back to non-Euclidean geometry. Sorry, I just realized I didn't have good pieces of chalk lined up yet, and that made me sad. Plan for today is we're going to continue our discussion of the betweenness axioms, focusing today on looking at a few different models of betweenness geometry, and maybe starting to choose some properties that have to be true. Got my usual office hours for the next couple days, and don't forget you have a homework set, homework 3, that will be due on Friday. I'm going to pass back the quizzes from last class. I'm not going to talk about them in class, and I haven't posted solutions yet because not everybody's taken the quiz yet, but once everybody does, I will have solutions up for you to look at, and then on Canvas, and I'll be happy to talk to you in the meantime about them if you would like. About the food. Oh yeah, what do circles and beaches have in common? What circles and beaches have in common is that both have tangents. Any questions or comments before we get started for today? So, I kind of like having quizzes every 3 classes. I feel like it's kind of the natural thing for quizzes. I was going to do that on Fridays, but then when we missed that one Friday when I was out sick, it's kind of become a Monday thing. Do y'all prefer quizzes on a different day of the week? Does anybody really care?
I like Fridays.
Would you like one this Friday?
I don't know. What would be? Didn't we just have one yesterday?
Yeah.
I think you have to skip a Friday and go back to Fridays.
Oh, so you want a super quiz next Friday then?
Okay, I take it back.
Yeah, I think at this point it's kind of just like, you might as well just stick with Mondays now, yeah. Mondays are fine.
We'll do Mondays for now. If we end up missing another day, we'll switch to a different day.
Alright.
Okay. So, if you recall from last time, we talked about the betweenness axioms. So we have our same 3 undefined terms as from incidence geometry of points, lines, and incidents. But we also have a new undefined term, which is what does it mean for a point B to be between A and C if A, B, and C are collinear. And we're introducing one undefined term and 4 axioms, the betweenness axioms, that we would like for this betweenness condition to satisfy. Where, if you recall, our 4 axioms, the first one said that if you have a point B that is between A and C, then the 3 points have to be distinct. B can't be between itself and something else. And if B is between A and C, then B has to be between C and A. So it's kind of a symmetric relation. It works backwards. Second betweenness axiom said that if you have 2 points B and D on a line, then you should always be able to find points, a point C that's between B and D, a point A that puts B in the middle, and a point E that puts D in the middle of B and E. So in other words, if you start with 2 points on a line, you can always find points in between and on either side. Betweenness axiom 3 says that if you have 3 points, 3 collinear points, exactly one of them has to be between the other 2. So B is between A and C. If B is between A and C, then you can't also have C be between A and B. It would totally break our intuition of how betweenness should work. And finally, our 4th condition related to being on the same and opposite sides of a line, where in condition A here, if we have a line, L, and A, B, and C are all off the line, that if A and B are on the same side of L, and B and C are on the same side of L, then A and C have to be on the same side of our line L. Anybody remind me, what did it mean to say that A and B are on the same side of L?
It means that segment AB does not intersect line L.
Yeah. If we say that A and B are on the same side of L, then if we take the line segment from A to B, that's not going to intersect L. So inherently, what this is saying is that if AB doesn't intersect L, and if BC doesn't intersect L, then AC can't possibly be allowed to intersect L as well. And similarly, kind of the second part of betweenness axiom 4 says if we have a scenario like this, where A and B are on opposite sides of the line L, meaning the segment from A to B intersects L, and if B and C are on opposite sides of the line L, meaning BC happens to intersect the line L, then AC, the segment from A to C, cannot possibly intersect L. So if A and B are on opposite sides and B and C are on opposite sides, then A and C have to be on the same side. And those were our 4 betweenness axioms, meaning axioms of what we would like our betweenness definition, whatever it ends up being, and whatever model we look at, to satisfy. Whenever we talk about a model of betweenness geometry, don't forget we also still want our 3 instance axioms to hold as well. Which I'm going to stop writing those out on the board because you all know them by now, or if not, then I pity your poor soul. But instance axiom 1, you may recall, is the one that says that's Euclid's first postulate, that given any 2 points, there exists a unique line between them. Instance axiom 2 is the one that said every line has at least 2 points on it. And instance axiom 3 is the one that said there exists 3 non-collinear points somewhere out there in space. So, before we go on to start looking at models of the betweenness axioms, anybody have any lingering questions from last class about what any of these meant? Yes, John?
Oh, I was just a question. So, a model for the betweenness axioms is also a model for incidence axioms.
Correct. Anything that's a model of the betweenness axioms is also going to be a model for the incidence axioms. You're just kind of forgetting about all the betweenness. But in general, you can have models for the incidence axioms that are not going to give us models for the betweenness axiom.
Okay.
For instance, as Megan, I think you pointed out last time, betweenness axiom 2 guarantees that in any betweenness axiom model, we have to have an infinite number of points. So our models of instance geometry that only have like 3 or 4 points aren't going to be able to be made into betweenness geometry models, because there won't be any way, unless we add a bunch more points, for those to satisfy betweenness axiom 2 here. Either questions or comments? So let's go on to looking at a few models. So the first model I want to look at is likely the model you're all thinking of when you intuitively think of betweenness axioms, which is going to be R2, where points are going to be ordered pairs of the form A comma B, where A and B are real numbers. So as a reminder, this symbol means is an element of. So when we say A comma B are elements of fancy R is a set of all real numbers, so this just means A and B are real numbers. So our points are coordinate pairs of real numbers. Our lines are going to be sets of points that are solutions to a linear equation ax plus by plus c is equal to 0 for some a, b, and c where either A is non-zero or B is non-zero. We're going to say that AB is incident to the line AX plus BY plus CZ is equal to 0 if AB satisfies, not CZ, this is doing two-dimensional geometry here, not three-dimensional. AB is incident to this line if AB satisfies the equation meaning that big A times little a plus big B times little b plus c is in fact equal to 0. And between this we'll come back to in a second. So this is all using a lot of fancy language here, but it means it's the way of lines that you're probably used to thinking about them. So if I were to give you the line, say, 2x plus y equals 0, for instance. This is going to define a set of points, define a line in this new model in R2. Brianna, can you give me a point that is going to be incident to this line?
1, 1. Oh wait, okay, let me think about this. 0, 0.
Okay, 0, 0. We plugged in 0 for x and y. That would certainly satisfy this equation. 2 times 0 plus 0 does give us 0. Katie, can you give me another point that satisfies this equation? Let's see, negative 1/2, 1. If we plugged in negative 1/2 for x, we get negative 1 plus 1. Yep, that's certainly going to do the job. And Emma, how about a point that is not going to be incident to this line?
2 and 2.
See, if we plugged in 2 for x and y, we'd get 2 times 2 plus 2. It's certainly not going to give us 0. So 2 comma 2 would be a point that's not incident to this line now, because it doesn't satisfy the equation. So this sort of gives us a way of looking at, of defining incidence model, a model of incidence geometry, and that our points are these coordinate pairs. Our lines are basically these sets of points that have this form, and incidence is defined the way you're probably used to thinking about it. If the point satisfies the line equation, then it's going to be incident to that line. If we wanted to draw this out as a graph, we could rewrite this and say, what, y equals negative 2x. So the points that satisfy this, so our line graphically would look like this. Elaine, we have 2 points on our line at 0, 0. We'll call that P1. And at negative 1/2, comma, Dr. Gerstle understands how lines work. And clearly this is a graph of y equals negative 2x instead of y equals 2x. Look at this nice negative slope we have going on here. Okay, that's our line. So 0, 0 is a point on our line, Elaine. Negative 1/2, comma 1 is going to be another point. We'll call this our A, and we'll call this our C. So Elaine, betweenness axiom 2 tells us we should be able to find some point in our line that's between A and C. Can you give me a point on this line that's going to be between A and C, according to your intuition of what you feel between should mean?
Negative 1/4, 1/2.
So negative 1/4, half, like that. Let's see, 2 times negative 1/4 is negative 1/2, plus 1/2 would give us 0. So that's certainly a point on the line, and you think this kind of satisfies what you feel betweenness should look like? Is everyone on board with that? Yeah, I would say so. In this model, it would be nice if we could say something like, negative a fourth, comma, negative, or comma, let's say positive 1/2 is between negative 1/2, comma 1 and the origin at 0, comma 0. Questions, comments? Nice dreaming thoughts if you're in Nathan's case. Okay, here's my challenge for you. I would like for you all to come up with a definition of betweenness for me for this model. So a definition that would make negative a fourth, comma a half in between negative a half, comma 1 and 0, 0, like Elaine would like it to be. But one that doesn't necessarily rely on intuition, one that definitely gives us some concrete definition of what it means to say that A1, comma A2, B1, B2, and C1, C2 satisfy this definition that B1, B2 is between the other 2 points. So go ahead and take a minute or two, and I encourage you to talk to your neighbors, as always, and see if you can come up with a definition that you're satisfied with for what it means for one point to be between these other 2 points in this model. Assuming an intuitive definition of betweenness that works the way you would expect it to graphically.
Are we only allowed to use these?
You're not allowed to use anything we haven't really defined. And you can certainly use something like A1 is less than B1. You can assume we have
That's
something.
all I want to use.
Okay, that's okay. You can use stuff like that. Like we're assuming, you know,
About to-
if you don't have that, then you're really
I was about to go into like ray, what's included in what ray.
I want some concrete condition that uses these 6 coordinates somehow.
Equality between. A1 has to be less than C1. Otherwise it
Negative 1/2.
I feel like
It's just gonna be like.
I'm saying, yeah, if
Yeah, I
A1 is
mean-
less than C1,
And so,
it's just like A1 is less than B1 is less than C.
Yeah.
that's C? Right.
Like that.
And you have to go based on the inputs.
I was gonna be like, no, yeah, negative 1/4 is between 0 and -1.
yeah, I guess that's.
I'll give you a hint. Whatever your definition you come up with, if these points are capital A, capital B, and capital C respectively, it needs to work in all 3 of these pictures.
Oh, okay. So the things we just, so we said like, A has to be less than like, okay. The x coordinate is A has to be less than the x coordinate of C, except that's not necessarily the
Negative
case.
1,
If they're like, you know, straight line.
0 and 2.
So in comparison,
So, or,
either or both.
yeah.
Mhm.
So we could say if
One
A1
half.
is less than B1 is less than C1.
Yeah, I mean, it's still holding the
So A and C can share either the same x coordinate or the same y coordinate, but they can't share both.
I propose it had to be on the
Okay.
line.
A2 is less than.
I'm just trying to get some.
Maybe it's use regular cases or the other direction.
1, 1,
Yes.
1, negative.
I mean, there's 4 cases.
2, 0.
There's like 6. No, wait, there's more.
Well, I'm doing it right
But
now.
I've created 4 cases. I think they cover everything.
There's 4 cases that you think cover
No,
everything?
no.
See what's right.
My definition is
it's all
4
good,
lines,
but-
but there's so many cases.
The between.
Maybe you said you have like 6
That's
cases.
The other two.
Well, I kind of, I mean, I don't know if you consider like A being the most left point for that second one. So different than C being the most left point because I don't think it really matters.
Well, we could have something that sort of fits one and then sort of say, or vice versa, and flip all of these equalities around. That's what I have in my notes. I'll just let you know.
It can't be or, because it's in one of those places and the other place it has to be A1 equals
I think when you have it.
All right, let's give it a few more seconds and then we'll come back together, see if we can agree on a definition as a class.
Like A1 is less than or equal to, A3, and B is strictly less than, or B1 is strictly less than, or whatever you're doing.
I think we're doing the same thing, but with X.
Because basically what we're saying is, I mean, obviously it's the polar or something floating around, but the two outside points can share the same x coordinate, or they can share the same y coordinate, or they can share neither, but they can't share them.
Right.
Yeah.
Because otherwise they'd be the same thing. It doesn't make sense.
So I wrote it in terms of like, you did the X.
Okay, it looks like things are starting to quiet down a little bit. Let's see. Megan, I'm curious to hear what you've come up with.
I feel like we made something cool, but that's okay.
That's what this class is all about, don't worry.
Exactly. So I said that betweenness is when either A1 is less than B1, which is less than C1, or A2 is less than B2, that is less than C2, or both.
Or both.
Yeah, I remember the first example. Oh, wait. It would have to be a combination of one of them being greater than, so, never mind, not the or both. But you could have it where, there's just 3 different cases, basically. So you could have it where you have A1 is less than B1 is less than C1. And then the A2, B2, and C2 are all equal. Or you could have it, yeah. And then you could have it where A1, B1, and C1 are equal to there. Or you could have it where A1,
I don't think this could, or both could hold anymore for this.
or both. Or you could have it where A1 is less than B1 is less than C1, and A2 is greater than B2. Or you could just flip the A and B. For all of those. But yeah, that's what I'm saying.
Is that your definition?
Yes.
Is everyone okay with that? It's hard to tell whether this works or not. Moral of the story is, and why I wanted you to do this, is to see how difficult it can be to come up with a definition that satisfies everything you might want it to. All right, Katie, before I get to you, I'm going to take a look at this. Actually, Katie, what were you going to say?
Oh, well, I was going to say that, do you have to mention that they're incident to the same line first? Because,
Yeah, technically we should say something like for collinear A, B, and C. Usually if you're talking about betweenness, it's kind of unnaturally understood that you're talking about collinear points to begin with.
I think I have a shorter way of saying the rest of that.
Ooh, okay.
Which was that.
Okay, let's see. Okay, Katie, what was your, what did you come up with? This is Megan.
So if B is between A and C, A star B star is star, or no, starting it. A sub 1 plus A sub 2 is less than B sub 1 plus B sub 2 is less than.
Hold on, you're gonna need to slow down for a second here.
Okay.
So if I have A between, so I have A is between B and C. If,
But it's to the same line, and A1 plus A2 is less than B1 plus B2 is less than C1 plus C2, or the same thing but with greater signs.
like that?
Yes.
That's interesting. I hadn't thought about one like this. I'll say the one I came up with is closer to negative. Let's see, does this work? Explain. Where did you come up with this, Katie?
Let's see. What did we say, John? What is it? Is it like?
I'm passing the buck to John.
Well, it seems like you're like projecting all the points onto a straight line,
Mhm.
and each projection has a unique point to project onto. So you always, and it'll always be between, the projection will always have the same betweenness as the actual line.
Okay, gotcha. So you're thinking about just treating all of these as being some one-dimensional surface, using fancy language like projection. What?
If you had the line just y equals negative x, then you could have b at 0, 0. So b1 plus b2 is 0, and then a at negative 1, 1, c at 1, negative 1. They would all be 0, not 1, 1.
Gadzooks. So what Elaine has suggested is that if you have these 3 points, what you'd like to say, 0, 0 is between negative 1 and 1, negative 1 on this line. All 3 of the sums that Katie come up with, come out to just 0, because the sum of the x and y coordinates in each case are always going to be the same. And in fact, I think if you took any point on this line, it would also give you the same sum of x plus y coordinate is 0. So this doesn't quite work for that one. It's an interesting idea, Katie, and I think it actually works for kind of for lots of lines. But there's going to be some counterexamples that cause this definition to fail if you're trying to do some sort of sum involving the individual coordinates without comparing the coordinates directly. Sydney?
We got confused with other inequalities, so we thought maybe we try and use like the definition of a line segment.
Oh, okay.
So we wanted to say that B would be on the line segment AC, but like we can't define it as insignificant because we already defined that.
So
we
B is
thought,
between.
Yeah, so we thought like saying the line segment AB and the line segment BC both have to be smaller than the line segment like AC.
What do you mean by smaller than?
Less than.
What do you mean by less than?
Whatever you see it for.
Whatever what?
Whatever we already used it for.
Well, so far we've only used less than to refer to individual numbers. Like 2 is less than 3, 3 is greater than negative 5. We don't have anything that gives us a way of measuring what does it mean yet for one line segment to be less than or greater than another one. I think once we get to the congruence axioms, which is going to be our next set of axioms that we're going to tack on, then we'll be able to do something like that. But I don't think we're quite there yet. And I think I agree that we can't use something like B is between A and C if B is on the line segment between A and C, because B being on the line segment between A and C means that B is between A and C. And so you basically be saying B is between A and C if B is between A and C in that case. And that's some circular logic that I'm not a huge fan of, if I'm being honest. I want to go back to, sorry, Katie. I think this is a clever idea, but it doesn't quite cover all cases. I want to go back to Megan's, because I think Megan's is the closest to what I have. So if the x coordinates are all less than each other, but the y coordinates are the same. So that would handle something like this case. If the y coordinates are all the same, but the x coordinates are different, which would handle something like this case, or in this case, plus the vice versa. Or if the x coordinates are all less than each other and the y coordinates are greater, so the x coordinates go like this, which would handle this case. What if we had a line like this?
You didn't draw that originally.
If you recall, I did draw that originally when I forgot what y equals negative 2x looks like. So it totally does count.
Would you have to include a case where your A2 is less than B2, less than C2? Yeah.
Like that? Okay, let's see. This handles horizontal lines. This handles vertical lines. This handles lines with positive slope. This handles lines with negative slope. This handles the exception. This handles the just and we need it to work backwards as well. I think this handles every case. Here's what I had. So what I had, and you can tell me if I made a mistake or not, because this is just something I came up with on my own, is A1 is less than B1 is less than C1, or we have that A1 is less than or equal to B1, less than or equal to C1, and A2 is less than B2 is less than C2, or same but with A's and C's flipped. So that's what I came up with. If the x coordinates kind of are all different, where B is in the middle of A and C, because in that case we could have something like this line with positive slope, or honestly that also is going to handle the line with slope of 0, the horizontal line as well at the same time. And the second case here is what I have to handle the vertical line, where B1 is potentially equal to A1 and C1, but the y-coordinate of B2 is in the middle of the y-coordinates of A2 and of A and C. And then, just like Megan, I had kind of a cop-out, or just do the same but flip the A's and C's in these two expressions. It's kind of the best that I could come up with for this. But I think the moral of the story is intuitive, and the reason why I wanted you to do this as an exercise is intuitively it may be obvious to say, come up with an idea of what does it mean for one point to be between the other two. And it might be easy to work with in the case that if I were to give you 3 points on the same line, you could probably pretty quickly tell me which of the 3 points is between the other two. But actually trying to come up with a sort of catch-all definition for betweenness in this model is actually very messy. It's messy to come up with something that can handle every possible case of what you might want points to satisfy, including vertical, horizontal lines, and lines with positive and negative slope to them. There's a lot of cases to consider, but intuitively it comes down to, is B on the middle linear graph? Any questions or comments about that? This isn't going to be the last time that something like this comes up. Something is intuitively maybe clear what we're talking about or what we're thinking about, but actually trying to come up with a precise definition is quite difficult. Or maybe not so much difficult as tedious. Okay, so So that's going to give us a model, R2, already erased the original stuff, for points and lines instance in betweenness in kind of the plane. Or points are just these coordinate pairs, and the lines, that they can be incident to or not, are going to be sets of points that satisfy this sort of linear equation. By the way, if we had something like ax plus by plus c equals 0, why did I say that either a has to be non-zero or b has to be non-zero? What would happen if both a and b were both 0 in this equation? Brown?
You wouldn't have a line forming because every point would end up being 0, 0.
Every point would 0, 0 is the only point?
Well, unless you had a scalar value for c, and then you would just have a constant equaling 0, and that's not good.
Yeah, I would say something along the lines of if a and b are both 0, the line would either be of the form c equals 0, which if c was in fact equal to 0, so your equation was like a pair of glasses, 0 equals 0, then every single point every single a comma b in the plane would satisfy it, and the entire plane would be a line, which we would kind of like to avoid. On the other hand, let's see. If we came out to an equation like 2 equals 0, which points in the plane are going to satisfy that equation for a line?
It just wouldn't exist. That's a contradiction in itself.
Yeah, no points in the plane would satisfy this equation, and so we'd end up having something that's a line with no points. In Becca, are we allowed to have lines with no points? Why not? Because instance axiom 2 tells us that lines have to have at least 2 points. And so our definition of a line as being something that satisfies this linear equation has to have that either A or B is non-zero, or potentially both, in order to have something that actually fits our definition of what we would like a line to be, assuming we don't want the empty sets to be a line, or the entire plane R2 to be a single line, which we probably don't. If the entire plane were a line, that would violate instance axiom 1, actually, because then I could say, oh, here's 2 points in the plane, and here's one line that goes between them, and here's another line that goes between them, and that would fail, then that would cause uniqueness of the line between those 2 points to then fail. So this is something that it's going to be important for us to do going forward, is to kind of pick apart these definitions. And I think it's good to try and see why do we need certain conditions to happen. So like why in our definition of line did we need that at least one of these two values, capital A and capital B, has to be non-zero. And it's because if we didn't require this, then we could get in some real nasty trouble involving our lines. Yes, Elaine?
No.
That's right. Any questions or comments about this model? So our next model is going to be very similar. It's going to be Q2, not R2. So in this model, basically, lines, incidents, and betweenness are going to work the same way as in our original model, but with the slight caveat that points are of form A comma B, where A and B are rational numbers. it mean for two numbers to be, or for a number to be rational? That?
It can be expressed as the quotient of, or as the ratio of two integers.
Exactly. Basically, rational numbers are numbers that can be written as fractions of integers. For A at least, A is going to be equal to some C over D for some integers C and D. So integers are counting numbers and they're negative. So like 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, 0, etc. We also need one extra condition. What is D not allowed to be equal to in a rational number? Right?
0.
What's that?
You can't divide by 0.
Don't divide by 0. Indeed. I actually forgot to include that in the packet, but in the packet, if you're going with what's written there, just say D not equal to 0. So this is going to be a model that's going to satisfy the axioms, both the instance and the betweenness axioms, and it's going to behave very similarly to the first model, R2, except you can have points in R2, like, I don't know, pi comma square root of 3. That's going to be a point in R2, but it's not going to be a point in Q2 because pi and square root of 3 are not rational numbers. So if I were to try and draw a graph of a line in our new model in Q2, the line would still look something like this, except if you zoom in on the line very close, you're going to have a bunch of holes in the line, because the only points that you're allowed to have are points with rational coordinates. So if our line was something like y equals 2x, we would allow in Q2 a point like, I don't know, 1 comma 2. Well, it took me an embarrassingly long time to find the y coordinate. Would check out, but a point like pi comma 2 pi would not be a point, even though it satisfies this equation, because this doesn't fit the definition of a point in Q2. It's only that fits the definition of a point in R2, because pi is irrational. Any questions, comments, or concerns? I have a question for you. We have two models of the betweenness axioms, R2 and Q2. Are they isomorphic? I guess before Jack uses real analysis knowledge to spoil the answer to that question, we should probably say, what does it mean for two models of betweenness geometry to actually be isomorphic? So let's write that out on maybe the next page. So what do you think we would... So if we have two models of the betweenness axiom, meaning two sets of definitions for these four terms that satisfy all the instance axioms and all the betweenness axioms, two, let's say, betweenness models are isomorphic, and if you recall, isomorphic meant mathematically the same, like meaning all the interesting propositions that hold true in one model hold true in the other, and vice versa. Anything that's false in one model has to be false in the other, and vice versa. We had some definitions that gave us that told us what it meant for two models to be isomorphic as instance geometry models. What would be something that you think would be nice to have in order to have two betweenness geometry models be isomorphic? John?
No, at least 3 points.
They both have to have at least 3 points? I think that's going to be true of any model, because you have to have 3 points for instance axiom 3, say. So I think the two models having to have at least 3 points aren't necessarily going to tell us something we wouldn't already have to have. One?
So the same three conditions that we already had, plus your one-to-one relationship has to maintain betweenness.
Ooh, okay. So you first of all want to say that if they're isomorphic as betweenness models, they have to also be isomorphic as instance models?
Yeah.
I like that. So let's require that. So let's have that. If they are isomorphic as models of instance geometry, and by that I mean we have this one-to-one correspondence between the points and lines of the first model and the second model, and P1 is instant to L1 if and only if f of P1 is instant to f of L1. So we have everything that we needed for them to be isomorphic as models of instance geometry. And Elaine, you had another condition. What was the other thing you wanted to have happen?
The same way that incidence is maintained through the one-to-one relationship, betweenness has to be maintained.
Ooh,
I don't know how you want to phrase that.
I would like to phrase it in a concrete way.
Would you like me to phrase it in a concrete way? Because I don't know if that's going to happen.
I mean, it'd be nice.
Okay. If B is between A and C in model 1, then B2 needs to be between A2 and C2 in model.
Okay, so let's say if f is our one-to-one correspondence of the points. So basically you're saying if B is between A and C, then you want f of B to be between f of A and f of C?
Yes, correct.
Does that sound reasonable to everyone? You make one slight tweak and I'll like it. Yeah, basically saying if B is between two other points in one model, then whatever they map to under our one-to-one correspondences of the points and from what it means to have an isomorphic instance geometry model, whatever points B, A, and C map to, if B is between A and C here, we want the point B maps to be between the points that A and C map to, and vice versa. If f of B is between f of A and f of C, we want B to have to be between A and C as well. So that's kind of a more concrete way, Elaine, of writing out what you said earlier, I think, which is we want betweenness to be maintained by our isomorphism. Megan, was that something similar to what you were going to say? Groovy. Any questions or comments about that? Basically, it's the same three conditions as from isomorphisms from the last packet. We're just adding a fourth condition that needs to be satisfied on top of that. All right, Jack, I'll let you answer this. Are R2 and Q2 going to be isomorphic then as models of betweenness geometry?
No, they're not.
Why not?
Because you can't, there is no one-to-one function between Q2 and R2.
Sure there is. F of x comma what? Well, from R2 to Q2. Okay, from R2 to Q2, you're correct. There is no one-to-one function.
Okay.
You can't make one going the other way around though.
Okay.
There's no one-to-one correspondence between R2 and Q2.
Yes.
I think is what you meant in yes. Why is that?
Because R2 is really, really big, and Q2 is big, but not really, really big.
Well, that sounds like a precise answer.
Real analysis.
R2 is uncountable and Q is countable.
That sounds like something with a more precise definition. So we're not going to get into what exactly Jack means in this class, but what I want you to take away from this is that R2 is not isomorphic to Q2 since they don't have the same number of points. And lines for that matter. But Dr. Gerstle, don't R2 and Q2 both have infinitely many points? Yes, but the infinity that's the number of points in the model for R2 is bigger than the infinity that's the number of points in Q2. R2 infinite number of points is greater than Q2's infinite number of points. And if you want to learn more, and I'm not going to go into detail, you don't need to know more detail about what that means, but if you want to learn more precisely what the heck, how can two sizes of infinity be different from each other, take real analysis this spring.
No, you have to ferment.
Steph, don't make me throw my chalk at you. Alright, have a good day, everybody. See you all on Friday. Take real analysis, because I think I'm going to be teaching.
Are you serious?
Yeah.
No, so hard teaching it.